So when looking to solve a pedigree and determining the inheritance pattern of a pedigree, you need to follow some steps in order to be able to do that. So when we first look at this, we're going to be looking to see the inheritance pattern if we can determine if a pedigree is an autosomal recessive trait, an autosomal dominant trait, if it's sex-linked recessive or sex-linked dominant, or if it's a Y-linked trait. And there are some rules that we need to follow when we're looking at these. So what we're looking at when we're determining if it's one of these inheritance patterns, we're always looking at the shaded individuals. And so one of the things that we need to be looking at is understanding what the shaded individuals will look like in each of these different things. So if it's an autosomal recessive, that means the shaded individual will have a genotype of homozygous recessive. If it's an autosomal dominant inheritance pattern, that means the shaded individuals will either be homozygous dominant or heterozygous for their genotype. If it's a sex-linked recessive, the individual for a female would be XX with two recessive X's, or for a boy, it would be that. Now, if it's sex-linked dominant, we would be then looking at the female would be this, or could be that, while then the boy would be that. And if it's Y-linked, it would be only found on the Y chromosome. So while we know something about all of the shaded individuals when we look at this from a different inheritance pattern, we also know something that's opposite about the not shaded ones. So we actually know something about each individual person in the pedigree. So the not shaded individuals, if it's autosomal recessive, that means that the not shaded individuals will either be homozygous dominant or heterozygous. They would be opposite of the shaded individuals. If it's an autosomal dominant inheritance pattern, the not shaded individuals would be homozygous recessive. So we actually do know something about each of these, and we can learn something about them by seeing what we know about each of the inheritance patterns and what we can tell from them. So this is how we would do this then. So we're first going to see if this is going to be an autosomal recessive pedigree. So what we want to do is we're going to then assume some things. First, we're going to assume that the shaded individuals have a homozygous recessive genotype, which means we also know that the not shaded individuals have to have a dominant allele. So what we would say is they would be this or this, and that's where we would determine, can dominant parents give recessive alleles to offspring? And the answer to that would be sure, is that if the parents were heterozygous, that then the father would be giving a recessive X to his son, and the mother's giving her recessive X to her son. We also know then that the not shaded individuals all have a dominant allele for one, and then we needed to figure out what would be the other one be? Remember, we could either have this or this. So again, it really doesn't matter what we have, but it does work out. So we would say yes as an example, that yes, this actually is an example of a autosomal recessive pedigree, and the parents' genotypes would be heterozygous. So that's just for one. Now what we would need to do is we would need to do that for autosomal dominant. So we're going to erase that and start again. So now if we're going to assume an autosomal dominant, what we're going to assume now is the shaded individuals are dominant, have a dominant allele, and the not shaded individuals are recessive. So what we would say is that this person is at least that, and everybody else who's not, we know is this. Well, then the question becomes, can recessive parents give a dominant allele? And the answer to that question that we know of is no. So we know that doesn't work. So once we get to the no, as soon as we get to a no answer, we're going to erase and start over. Now we're going to look at this from a perspective of sex-linked recessive. So again, we're going to assume now that the shaded individual would be sex-linked recessive trait inheritance pattern. So what we would write down is we would know then that this is a boy, so he's XY, and we're assuming that it's a recessive X. Well, then what we're going to write down is our X and our Ys. And because these are not shaded, we would know that they're not recessive X's, but dominant X's. So he has a dominant X. We know she has a dominant X, but we don't know the other one. So we got to figure out if we can determine what that is. Well, again, the father is going to donate the Y, or he's going to give the Y to his son. So this recessive X has to be coming from mom. So if we put a recessive X there, we know that that works for the son, for this son. We now need to figure out, can we also do the same thing for this son? So we would know, again, that he is XY, but he has to have a dominant X this time. So again, the Y is coming from dad, the dominant X is coming from mom. So that works. We know the girls are going to be XX with at least one dominant X. So again, dad now is going to give the dominant X to the daughters. Mom can give either X to her daughter. So let's just say one gets that and the other gets that. And that works as an inheritance pattern for a sex-linked recessive. So we would again circle that as a yes. We would write down the father as XY with a dominant X and mom as being XX with heterozygous X's. Now, again, we need to start all over again, so to figure out if this is also going to be then let's say if it's going to be an X-linked dominant one. So if it's an X-linked dominant, that means that the shaded individual now has a dominant X, and we know then that the not shaded individuals have recessive X's. And we then go, can this male who's getting the Y from his father get a dominant X from a mother who has two recessive X's? And the answer to that question is no. So what we would say then is no. Once we get to the no, we erase. And that's how we would solve then for pedigrees, is we have to know what the shaded individuals' genotypes are. We have to know what the not shaded individual genotypes are going to be as well. And then we have to figure out can we inherit then from generation to generation, from parents to offspring, and make those rules work. If they can, then we know that that's an example of that inheritance pattern. If it's not, then we know it's not. So this one pedigree shows both an autosomal recessive inheritance pattern and a sex-linked recessive inheritance pattern. That's how you would go through and solve the rest of these then, 2 along with 3 and 4. Okay? So if you have any questions, let me know. Thanks.